We have here limit x tends to 0 sin square x by under root 2 minus under root 1 plus cos x. Sin x is 0 when x equal to 0 and 1 plus cos x will be 2, and here in denominator also we have under root 2 minus under root 2. Right, basically we have 0 by 0 form. We have to do some kind of manipulation to get to make this denominator non-zero. Right. So let us do some basic trigonometric manipulation. Cos 2 theta. We know what is cos 2 theta. It is 2 cos square theta minus 1. Right. Cos 2 theta is 2 cos square theta minus 1. What is 1 plus cos 2 theta? It is 2 cos square theta. So, right. This is in the form of 1 plus cos 2 theta. We'll write it as 2 cos square theta. Right. 2 cos square x by 2. Right. Under root of 2 cos square x by 2. Under root 2 cos square x by 2, we can write this, which is nothing but under root cos x by 2. Right. So we have under root 2 minus under root cos x by 2. We can take this under root 2 common. Then we'll write it as under root 2 into 1 minus cos x by 2. Now again, 1 cos 2 theta is again 1 minus 2 sin square theta. Right. 1 minus 2 sin square theta. So 1 minus cos 2 theta is 2 sin square theta. Right. So we can again manipulate this. 1 minus cos 2 theta in the form of 1 minus cos 2 theta is equal to again 2 sin square theta. Right. That is nothing but 2 sin square x by 2 by 2, which is x by 4. 2 sin square x by 4. We have this root 2 and this part will become 2 sin square x by 4. Right. We still not we have still zeros in numerator and denominator. But we have got this into sin x by x format. Right. We have sin square here also, sin square here also. We can divide and multiply with x square. Right. So we have got that into sin x by x format. That is easy for us, right? So sin square x by 2 sin square x by 4. Right. We know this limit. We can directly use it. This will be what we'll do. We'll try to simplify this, right? Here in the sin square x, we need some x square in the denominator also. We need some x square in the numerator. And then we'll multiply by 4 also, by 4 here also. Basically, this sin square x by this x square, right? And this sin square x by 4 by this one, this x by 4. Basically, we have sin square x by x square by sin square x by 4 by, sorry, we have to do it with 16, right? By x square by 16, right? This one. So what will be left? Will be left. So this part, this one will become 1 and this one will become 1. We'll be left with 16 by 2 root 2. Right, 16 by 2 root 2, which is nothing but 8 by root 2, which is nothing but 4 root 2, which is 4 into 2 by root 2, which is nothing but 4 root 2. So 4 root 2 is the correct answer. Right. So when we are dealing with signs in both numerator and denominator, we have to be careful with the while taking care of the fractions. What we have, sin square x by sin square x by 4. Right. We want one x square for this, another x square for this. So that's why we multiply with x square and divide with x square. Okay, this x square belongs to this. Right. And this x square belongs to this. Right. But here we want x square by 16. Right. So that's why we multiply and divide again by 16. So this x square by 16 belongs to this basically. And this 16 will be left. Right. So ultimately this gets converted to sin square x by x square by sin square x by 4 by x square by 16. And we have this 16 left and 16 by 2 root 2. We have to be little careful. Please note one very important thing. When we say limit theta tends to 0, it should be sin theta by theta. Right, we cannot say sin 2 theta by theta, this is equal to 1. We cannot say sin 2 theta by theta equals to 1. Right. So though both 2 theta and theta, both they tend to 0, we cannot say this is equal to 1. Okay, so this should be equal to 2. This should be equal to 2. This limit is equal to 2. Right, we make it 2 theta also and we multiply and divide with this. This should be equal to, this limit is not equal to 1, this limit is equal to 2. Okay, please understand the graphical significance also. When theta is very small, like this, when theta, when theta is very small, then theta is equal to sine theta. Right. Similarly, when theta is very small, then sine 2 theta is equal to should be equal to 2 theta, not theta. Right. So then sine 2 theta by theta, if you have to make this limit, when theta is very small, this should be equal to 2 theta by theta, which is equal to 2. Right, not 1. Right, please note, though both are tending to 0, it should be equal to 2. Please look at the graphical significance of this. This is sine theta, this blue line, and this line is theta, or sine x and x. Okay, sine x, this graph is sine x, and this blue line is x, y equal to x, and this is y equal to sin x. Our regular sine graph. This is our pi 3.1. This is our 2 pi 6.2. Right. The graph goes like this. Our regular sine curve. Now this is our line y equal to x. When this line, when theta or x comes closer to 0, this line and this curve of sin x are actually coinciding. Right. That's why, and obviously this line is always, x is always greater than sin x. Right, x is always greater than sin x, but when they come close to 0, they become very close. Right, so that's why sin x by x will tend to become 1. Will tend to become 1. Right, because they become so close, they tend to become 1. The sign, it becomes 0.9, it becomes 0.999, whatever, and it tends to become 1. Whereas, look at this graph. This is actually 2x. Sine, this is, and this red graph is again, red curve is again sine 2x. Sine 2x, obviously, it will be compressed by 2 times, right? In 1 pi, it would have covered the entire cycle, right? They are meeting here, and while it makes a half curve, the green curve will make a full curve, right? Right. So because it is 2x, it is compressed by 2 times. Right. Now this 2x, when it comes closer to 0, this 2x would be equal to this line 2x, not this line x. Right. Please look at the slope of this graph. Right, this red graph, this red sin x, which is sin 2x, which is sin 2x when 2x is coming closer to 0, or x is coming closer to 0, this is closer to 2x, not closer to x. This is closer to 2x. You see, these lines are closer. The red lines are closer, not the red and blue. Right. So that's why if you have to write sin 2x by x, 2x by x, it should be equal to 2. It is not equal to 1. Right, there's a huge difference between these red and blue lines, right? So that's the difference. So please always take care when you are using this sine theta by theta when theta tends to 0. Right, we should be careful if there is some multiple of theta within the sine, so same multiple of theta should be there in the denominator also. This is very important. Right, guys? Thank you.